Okay, pre-calculus. 2 assignments this week. There's supposed to be 3, but I'm going to cut off one of them because the third one is just a review of the first 2. So, 2 assignments. 2 this week. And it is dealing with radians, which is what we covered last week. We spent a whole week on that for a reason. Yeah. Anyways, this week we're doing equation to graph in radians. And then next week we're going to do graph to equation in radians. So buckle up. The main thing you have to understand is this. When you're doing a degree problem, you use 360 to find the period. When you're doing a radian problem, you're going to use 2 pi to find the period. So there are 2 types of problems. I will show you. Lesson 1, by the way, is just graphing sine, cosine, secant, cosecant, because, if you graph sine, then you can graph cosecant. There's not a big difference. And if you can graph cosine, then you can graph secant. Not a big difference. Type 1. Type 1 is when the frequency is written in radians. Example, y equals 3 plus 2 times the sine of pi fourths. Yeah, I don't like it. You don't like it. None of us like it. X minus 6. Voila. So, a couple of things. There are 2 indications that this is a radian problem and not a degree problem. Number 1, that is not a subtle indication. You see pi, you know right away it is a radian problem. But subtle. In all the problems previously, we used theta there. Theta means degrees, and x means radians, generally speaking. Or at least that's what this author does, by the way. So, when I say this author, I mean the author of our book. Alright, so, and also one of the difference, we're used to calling this the sinusoidal axis. For some reason, on the assignments, they're calling it the vertical displacement. Horizontal displacement, vertical displacement. So, whatever. This is still going to be the amplitude. This is still the frequency. This is still the phase displacement. Yeah. 3 is the sinusoidal axis. 1, 2, 3. And amplitude is 2, 4, 5. And then 1. So that's the top of the road, middle of the road, bottom of the road. And the phase displacement is 6, so I guess, I could just do 6 tick marks. But I'm nervous, so I'm not going to do it yet. We know the frequency is pi fourths. So normally, to find the period in a degree problem, you would do 360 divided by frequency. Yeah? But, no bueno. We're doing a radian problem. So because we're doing a radian problem, you're going to go 2 pi divided by the frequency. Pi fourths. I told you, buckle up, people. Buckle up. Hopefully I do a good job explaining. Here we go. The pi's are going to cancel. Yeah? Dun. Cancel. What is left over, though, is like a 1. I've said this many times in class. There's no such thing as canceling. Things either equal out to 1 or equal out to 0. In this case, a pi divided by a pi is a 1 and a 1. Yeah? Anyways, so you end up getting 2 divided by 1/4, which is 8. Yeah? Do you want me to go through that? I see some of you shaking your heads, like we need to go back, review some fraction work. Okay, so 2 divided by 1/4 is the same as 2 divided by 1/4. Yeah? And then keep it, change it, flip it. Keep it the same, change that to multiplication, flip it. And look at that. That's where you get 8 from. Okay. Do I need to see this work? No. Do I need to see that 2 pi divided by pi/4 is equal to 2 over 1/4, which equals 8? Yes, I want to see that. The canceling? Not necessary. So, the period is 8. Phase displacement is 6. So actually on these type of problems, type 1, your graph can be very accurate. That's what I like about these. So, 1, 2, 3, 4, 5, 6. Voila! Remember before all the other problems I was making you guess, like just put a random point out there and we'll call it 6. This time we're not guessing. And the period is 8, so we're going to go all the way out to 14. Because remember, this plus this tells you where the end of the cycle is. Anyways, we need 8 tick mark. 1, 2, 3, 4, 5, 6, 7, 8. Which makes that 14. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And sine, we're graphing sine. Sine starts in the middle. That wasn't too bad, huh? And then it, oh shoot. Boom, boom, cut that in half. Cut that in half. Cut that in half. Okay. Middle. Top. Back to the middle. Bottom. And back to the middle. One full cycle. And bam, bam, bam. Beautiful. Sine starts in the middle. Cosine starts at the top. Yeah? If we were graphing cosecant, the difference is we would have an asymptote here, asymptote here, and an asymptote here, and then you just flip this part upside down, essentially. That's a crude way of explaining it. It's not actually accurate, but, and then this part of it, you flip it this way. But good enough, yeah? Type 2. This is much harder. Much harder for students. This time, the frequency isn't in radians, but the phase displacement is. This is, whew, you're gonna kick your butt. Kick your butt. By the way, before I actually do an example, the phase displacement is in radians. Okay, they're going to ask a question about spacing. I don't really care about this. If you leave it blank, whatever. But here's what they're asking for. You know how a circle has 4 parts, a cycle has 4 parts. So to figure out your spacing, you're going to take this number and you're going to divide it into by 4. So your spacing is 2. So what does that tell you? Go 6, 8, 10, 12, 14. Basically, it's telling you to count by 2s. Yeah? I guess that's a little bit important. Whatever. Ooh. Remember that. Let's go -5 plus 2. So, secant. Ooh, secant. Do you remember if secant is sine or cosine? Better remember, shoot. And let's go with 3 for the frequency. And then we're going to go x minus 5 pi sixths. I know what you're thinking. I'm thinking the same thing too. What the bleep is that? Okay. Sinusoidal axis, amplitude, frequency, phase displacement. And again, like I said, this is also called the vertical displacement. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7 is the bottom of the road. Okay, so we've got our road, bottom, middle, top. Over here, I'm going to do the work for period. Again, the main thing to remember is we're not doing 360 divided by frequency. We're doing 2 pi divided by the frequency, which in this case is 3. Oh, shoot. 2 pi divided by 3. Now, if you can reduce. Trust me, it's going to save your life. And spacing. We're supposed to take this and divide it into fourths. Yeah? That's so ugly. So I teach you something else in a second while I'm thinking. Got a 3 here and a 6 there. We can easily get a common denominator of 6. So I could rewrite that as 4 pi over 6, yeah? I know that's weird to go backwards. Normally you want to reduce fractions, but in this case you want the denominators to match. It's going to help you with counting tremendously. So I'm going to do something bizarre. I'm going to make this bigger. It's still an equivalent fraction, so 2/3 is the same as 4/6. Yeah? Okay. This time I am going to make just a random point out here because A, these problems are harder. B, oh my gosh, how are we at the 13-minute mark? Alright, I'm going to do this as fast as I can. So, phase displacement is 5 pi sixths. And then I'm going to put a mark out here. 5 pi 6 plus 4 pi 6 is 9 pi 6. Let me do that again. 5 pi 6 plus 4 pi 6 is 9 pi 6. Yeah? And spacing, don't really care. I really don't care about the spacing, by the way. But obviously, what's in between 9 and 5? 7 pi 6. You can do that. What's in between 5, 6, and 7, 6? 6, 6. What's in between 7, 6, and 9, 6? 8, 6. So it's not that hard to figure out the spacing, yeah? 6. Okay, it might be kind of hard to write it though. Okay, recap. Always 100% of the time. Phase displacement plus period equals end of cycle. Phase displacement plus period equals end of cycle. And if everything has the same denominator, it's super easy to count, yeah? Anyways, secant is cosine, so cosine starts at the top of the road, and then it goes to the middle, and then it goes to the bottom, and then it goes back to the middle, and then it goes back to the top. Remember, I'm not graphing cosine, I'm graphing secant, so I'm going to go like that, and then the asymptotes occur when the function, the parent function, hits the middle of the road. So right here, dun, 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 is a vertical asymptote. And right here is another vertical asymptote. And then this is secant. Makes like a horseshoe shape. Not a parabola. And then there's another one here, like that. Bam. Bam. I could do this, but I don't like it. It looks like a double horn, so I'm going to just do this one over here. That, to me, looks a lot better. Voila! Remember, cycle has 4 parts. That has 1, 2, 3, 4 parts. I know what you're thinking. That's beautiful. Where'd I get this pink pen? Just bought it today. Yeah. We're at the 16-minute mark. I hope YouTube lets me upload. Anyway, 8 problems like that. It's either type 1 or type 2. And, yeah. You might have to rewatch the whole fraction part a couple times. Email me if you have trouble.